This is 4.3, multiply and divide mixed numbers in complex fractions from OpenStax PreAlgebra, and we're going to be doing section B, translate phrases to expressions with fractions, and C, simplify complex fractions. So let's go ahead and start with section B, translate phrases into expressions with fractions. And we've worked a lot with translating phrases into expressions with adding, subtracting, multiplying, and dividing. Now we're going to do it with fractions. So we're just adding in one more step. You guys already know how to do this. And so let's review some terms. Quotient and ratio are often used to describe fractions. So let's talk about each of those. Remember that quotient refers to the result of division. So any answer that you get from a division problem is a quotient, whether it's written as 3, oops, sorry, gotta get my pen here, 3 divided into 9. This 3 would be the quotient, or whether it's written as 16 divided by 4. This 4 would be the quotient. Okay, so any type of division, regardless of how it's written, 20 divided by 5, this 4 is the quotient. Okay, so those are quotients. Now, ratio is a comparison of two numbers written as a fraction. So an example of this would be a 1-to-3 ratio, or a 2-to-3 ratio, right? And remember, if you remember back to when you talked about ratios before, they can also be written this way, or 1-to-3, or 2-to-3, right? These are ratios. But in this case, we're going to be talking about them in terms of fractions because we are working with fractions at this point. So let's look at an example. Translate the phrase into an algebraic expression. The quotient of 3x and 8, and the order is so important. Okay, we have two expressions. We have 3x and we have 8. Okay, so we're going to turn this into one expression, the quotient of 3x and 8. So we know we're dividing and we're working with fractions. Let's just put a fraction bar there. The quotient of your first, whatever you come to first, is going to go on the top. The quotient of 3x and 8. And that's it. That's how you translate this phrase into an algebraic expression. So it turns into 3x divided by 8. The quotient of 3x and 8. Okay, so you're going to do some try-its. Go ahead and read these. The quotient of 9s and 14. The quotient of 5y and 6. Pause your video, write what you think it is on your paper, and then come back. So let's start with the quotient of 9s and 14. We're dealing with division, right? We have quotient, so we're going to put a fraction bar there. The quotient of 9s and 14. Quotient of 9s and 14. And this is what you should have gotten for the first one. The second one, quotient, once again we're dividing, we'll put a fraction bar. The quotient of 5y and 6. And that is the answer for the second one. Check your answers, make sure they match with mine. Here's another example. This one gets a little more complicated because it has more pieces of information there. So we're still translating the phrase into an algebraic expression, but we have the quotient of the difference of m and n and p. Okay, so we have some extra steps in here. We have the difference, and instead of having two expressions, we have 3 different expressions. So we have quotient, which we know it means we're going to be dividing. So we have something here and something here, and then we also have difference. Remember back, difference means we have something minus something, okay? So the quotient of the difference of m and n and p. Now, how do you know what to do first? We have quotient and difference. So we're going to work on the inside first and then work our way out. So what it might help is if you put parentheses around what's on the inside. The difference of m and n, and then we're taking the quotient of that and p. So let's write the difference of m and n. And remember, order order matters in this too. Whatever you come to first, that's what you're going to put first. M minus n, okay, that's the difference of m and n is m minus n. Okay, so now we're going to take the quotient of that and p. So the quotient of m and n and p. Okay, so here, instead of having, like we did in the previous examples and try-its, instead of having one term, we have a whole expression, m minus n, all divided by p. So it really helps to put parentheses there to separate the parts of the problem. So let's go ahead and look at some try-it problems. You have the quotient of the difference of a and b and cd, the quotient of the sum of p and q and r. Okay, so pause the video and then come back and check your answer. Okay, the quotient of the difference of a and b and cd. Okay, so I know I'm dealing with a quotient here, but first I want to deal with what's inside these parentheses that I just added. The difference of a and b is going to be a minus b. And then I'm taking the quotient of that and CD. And this is what you should have gotten for the first one. Next, the quotient of the sum of P and Q and R. Now sum means we're adding, right? So we're going to do P plus Q, but then we're taking the quotient of that and R. So the quotient of that and R, and this is what you should have got for the second one. Okay, check your answer there. So let's move on to section C, simplify complex fractions. There are multiple types of fractions. We've already talked about a bunch of them. We talked about proper fractions, right? A proper fraction is when you have, for example, you have 1/3. You have a smaller number on the top and you have a larger number on the bottom. It doesn't matter what those numbers are as long as the number on the top is smaller than the bottom. We call those proper fractions. The next type of fraction that we talked about was improper fractions, right? And those are when it's the opposite, when the number on the top is larger than the number on the bottom. And once again, it doesn't matter what numbers those are, but the number on the top is larger than the number on the bottom. Then we also had mixed numbers, right? And that's when you take an improper fraction and you turn it into a whole number plus a proper fraction. So in our example here of 10/9, 10/9 as a mixed number would be 1 1/9, right? So mixed numbers, 3 3/4, 10 5/8, right? You have a whole number plus a proper fraction. The next type of fraction that we haven't talked about in class yet is complex fractions. So we're going to talk about what complex fractions are, and then we're going to learn how to work with them. So complex fraction, defined, is a fraction in which the numerator, denominator, or both contain a fraction. So you can summarize this as, oops, I can't spell and write at the same time, a fraction in a fraction. Okay, a fraction in a fraction. So some examples of this would be 6/7 over 3. Okay, here we have a numerator of 6/7 and a denominator of 3. Now, how do I know that this is 6/7 as the numerator and 3 as the denominator, and not 6 as the numerator and 7/3 as the denominator? It's because of the size, right? You can see that, let me change my color here. This fraction bar is larger, so that's the main fraction bar, and then this fraction bar is smaller, so that means that this fraction goes together as the numerator, and then everything under the larger one is the denominator. Okay, so that's one example where you have a fraction on the top and then a whole number on the bottom. Another example would be the opposite, where you have a whole number, a whole number on the top, right? That's your denominator, and your numerator is a fraction. And then over here we have, where we have both, a fraction on the top, as the numerator, and a fraction as the denominator. And then lastly, same thing where you have a fraction as the numerator and a fraction as the denominator, but we have a variable in there. And any of these can have variables, okay? You can have variables in any of these forms. And so those are complex fractions, okay? Which makes sense. Complex means difficult or lots of parts. This is a fraction and a fraction, and that makes it complex. So that is what a complex fraction is. Let's talk about how to simplify complex fractions. To simplify complex fractions, remember that the fraction bar means division. Okay, that's all you have to remember. So rewrite the complex fraction as a division problem, follow the rules for dividing fractions, and then simplify if possible. Okay, rewrite the complex fraction as a division problem, follow the rules for dividing fractions, and simplify if possible. So let's see what this looks like when we actually pull up a problem here. So example 4.43, simplify. 3/4 is our numerator. I'm going to put a box around that to help myself. And 5/8 is the denominator. Okay, so let me go back and let's look at our steps. First, we're going to rewrite the complex fraction as a division problem. Okay, so if I have 3/4 as the numerator and 5/8 as the denominator, what that actually means in division is 3/4 divided by, oops, not 8, 5, I flipped it over. 3/4 divided by 5/8. Right? Because this fraction bar here means division. So I can rewrite it in a form that is recognizable to us. And you guys know how to do this. We just did this, right? So we rewrite the complex fraction as a division problem. Then we follow the rules for division. And we know that when we're dividing by a fraction, we rewrite it as a multiplication problem. So here we're having to rewrite twice. Rewrite the complex fraction as a division problem, rewrite the division problem as a multiplication problem. And when we do that, we multiply by the reciprocal. Okay? And then we can either multiply straight across and then reduce, or we can reduce and then multiply across. Let's go ahead and do 3 times 8 divided by 4 times 5. And then I'm going to factor the 8. I know that 8 is 4 times 2, 4 times 5. And I have a 4 on the top and a 4 on the bottom, so I can cancel those out. And that leaves me with 3 times 2 divided over 5, or divided by 5, which is equal to 6/5. Okay, so now this is our answer. And what kind of a fraction is this? This is an improper fraction. And remember, in algebra, we are going to leave that as an improper fraction. Do not turn it into a mixed number unless otherwise told, okay? So always leave it as an improper fraction. Okay, so that is how you simplify or simplify complex fractions. So I'm going to go ahead and put up some try it problems for you. Before I tell you to pause it, I'm going to, oops, sorry. Let's see, we did that, okay. But I'm going to help you out. We're going to put boxes around the numerators. That's a numerator, that's a denominator, okay, to help you see it. Here's a numerator, here's a denominator. Okay, so remember, you're going to rewrite these as division problems, follow the rules of division, and simplify if possible. So pause your video, work these out, and then come back. I'm going to rewrite this first one as a division problem. 2/3 divided by 5/6. And then I'm going to rewrite the division problem as a multiplication problem. So it's 2/3 times 6/5. Okay, and then I'm going to do 2 times 6 divided by 3 times 5. And I see that I have a 3 on the bottom and I have a 6 on the top. And I know that 6 is divisible by 3. So I'm going to factor out my 6. 3 times 2, 3 times 5, and then I can, oops, sorry, this I miscopied. This was not a 3, this should have been a 2. Sorry guys. So this is a 2, right? Because I have the 2 from here, and then the 6 turns into 3 times 2. I can cancel out the 3's, and I'm left with 4 divided by 5. And that cannot be simplified any further. There is no number other than 1 that can go evenly into 4 or 5, so this is my answer. And I'm going to leave it as 4/5. Okay, next one. I'm going to rewrite the complex fraction as a division problem. 3/7 divided by 6/11. And then I'm going to rewrite the division problem as a multiplication problem. 3/7 times 11/6. I get 3 times 11 divided by 7 times 6. And I notice that I have a 3 on the top and a 6 on the bottom, so I can factor out the 6 and get rid of the 3. 3 times 11 divided by 7 times 3 times 2. Get rid of those 3's, and I'm left with 11. 7 times 2, that's equal to 11/14. And that is my solution, 11/14. Check your answers. If you didn't understand why you got it wrong, watch it again or let me know and I can help you. So let's do another example. So here, this one's different because we only have a fraction as the numerator and we have a negative. But the way we do this does not change. We're going to do it the exact same way. So we're going to change this into a division problem. We're going to have negative 6/7 divided by 3. And then I'm going to change this 3 into a fraction. Negative 6/7 divided by 3/1, right? Any whole number can be changed into a fraction by putting it over 1. And then I'm going to rewrite this as a multiplication problem. Negative 6 divided by 7 times 1/3. And then I'm going to multiply straight across, okay? Negative 6 times 1 is negative 6, right? A negative times a positive is a negative. 7 times 3 is 21. Now, as I look at this, I see that negative 6 is divisible by 3 and 21 is divisible by 3. So I'm going to factor those out. I'm going to come down here. So negative 6 is equal to negative 2 times 3, and 21 is equal to 7 times 3. So I'm going to cancel out those 3's, and I get negative 2/7. And that is my answer. Okay, so even though we started with a negative and with a whole number on the bottom, same process. Change it to a division problem, apply the rules of division for fractions, and then get your answer and simplify if possible. So let me put up some try it problems for you. Go ahead and try these and pause your video and then come back. So the first one I'm going to change into a division problem, negative 8/7 divided by 4. Now I want to change the 4 into a fraction, divided by 4/1. And then I'm going to change, once again I have to make another change. I'm going to change the division problem into a multiplication problem by multiplying times the reciprocal. And then I could multiply straight across and then reduce, but I noticed that a negative 8 is divisible by 4 and we have a 4 on the bottom. So I'm going to factor this out. Negative 2 times 4 is the negative 8, and then times 1. I can write it, I don't have to. I know the 1's going to disappear. And then 7 times 4, cross out the 4's. And on the top I have negative 2 times 1, which is negative 2. And on the bottom I have 7. Negative 2/7. That's a really weird 7. Sorry about that. Okay. Next one. This one, it has fractions on the top and the bottom, but it also has a negative. So let's apply the same process. Let's rewrite this as a division problem. Negative 3/9 divided by 9/10. And then I'm going to rewrite that as a multiplication problem. Negative 3/9 times 10 divided by 9. There we go. And then I can either multiply and then reduce, or I can reduce and then multiply. I notice that I have 3 on the top and a 9 on the bottom. And I actually have 2 9s I could work with. But let's go ahead and do negative 3 times 10. And then I'm just going to factor out one of these 9s. 3 times 3 times 9. Okay, and then the 3's cancel out, but remember the negative stays there. So I have negative times 10, or negative 1 times 10, that's negative 10. And then on the bottom I have 3 times 9, which is 27. Okay, then I want to check, is there anything that can divide evenly into negative 10 and into negative 27? Nope, nothing can divide evenly into those, so that is reduced. And my answer is negative 10 over 27. Oops, I did that wrong. No, I did that right. 9 times 9. Yeah, okay. So negative 10 over 27. Sorry guys, I questioned myself. Maybe I did do it wrong. If I did it wrong, let me know in the comments on Google Classroom. So check your answers. If you need to, rewatch that. Okay, here's another one. Now we're doing the same thing, but we're throwing in some variables. And I know some of you guys freak out and forget what to do when you see variables there, right? Remember, treat them the same as numbers. We're still going to do the same process. So let me go ahead and write the process. First, we're going to rewrite as a division problem. Okay, then we're going to apply the rules of division, and then we are going to simplify if necessary. Okay, so we still use the same process. So let's rewrite this as a division problem. If you need to, put a box around your fractions that are inside the fraction. Okay, so x divided by 2, x over 2, divided by xy over 6. Okay, so we rewrote it as a division problem. Next, we're going to apply the rules of division. So if I'm dividing this fraction by this fraction, even though it has variables, I'm going to rewrite it as a multiplication problem using the reciprocal of xy over 6. So x divided by 2 times, flip this over, 6 divided by xy. Okay, and then I know I can multiply straight across, but I also see that I have some common factors in the top and the bottom. I have an x on the top and an x on the bottom. Also, if I factor out the 6, I can pull a 2 out, and there's already a 2 on the bottom. So I'm going to write this as x times 2 times 3, right? X times 2 times 3 is 6, times 6, over 2 times x times y, right? When two numbers are right against each other, that means we're multiplying them, so we could pull them apart and put the dot in there. Now I'm going to go ahead and cancel out things that I have in the top and the bottom. I'm going to get rid of my x's, I'm going to get rid of my 2's, and that leaves us with a 3 on the top and a y on the bottom. And that is my solution, okay? Do not be afraid if you end up with letters, right? It is okay in algebra to end up with letters. Do not let that confuse you, okay? When there's letters thrown in, you treat it the same exact way as you would if there were numbers. So here are your two try-it problems. You have a divided by 8, a over 8, and you have AB over 6 as your numerator and your denominator. And then on the bottom, you have P over 2 divided by PQ over 8. So there I've identified your numerator and your denominator for you. And so remember, you're not going to do this any different than before. Remember, your first step is you are going to rewrite as a division problem. Second, you are going to apply the rules of division, and then third, you are going to simplify. Okay, so pause the video, go ahead and work those out, and then come back and see if you got it right. I'm going to start by rewriting this as a division problem. A over 8 divided by AB over 6. Now I'm going to apply the rules of division, which means I'm going to rewrite this as a multiplication problem. A over 8 times, flip this over, 6 over AB. Now I notice I have an A in the top and an A in the bottom. Awesome, those are going to cancel out. These ones, the 6 and the 8, I know that both of those are divisible by 2. So I'm going to pull out a 2. A times 2 times 3, right? 6 is 2 times 3, divided by 8 is 2 times 4, and then times A times B. Now I can go through and I can get rid of things that are in the top and in the bottom. Get rid of the A's and get rid of the 2's. And then that leaves me with 3 on the top and 4B on the bottom. 4B, and this is my solution, 3 over 4B. Next one, I'm going to rewrite as a division problem. P over 2 divided by PQ over 8. Then I'm going to apply the rules of division by changing it to a multiplication problem. 8 over PQ. Okay, and then when I rewrite it on over here, I'm going to notice that I have a 2 here and I have an 8. 8 is divisible by 2, so I'm going to factor out a 2. P times 2 times 4, right? 2 times 4 is 8, divided by 2 times P times Q. And then I can cancel out things that are on the top and the bottom, get rid of my 2's, get rid of my P on the top and the bottom, and I'm left with 4 over Q. This is your answer. Check your answers. If you didn't understand how we got that, go ahead and rewatch it again. If you need more help than that, go ahead and send me an email or ask me to help you out. So another example here. I think this is the last example, and then we'll have 2 more try-its and then your assignment. Simplify 2 3/4 over 1/8. Now, what's different about this one than all the other ones we've done is that we have a mixed number as the numerator, and then we have a fraction as the denominator. Okay, you guys already know how to do this. Okay, so first we're gonna follow the same rules. We're going to rewrite as a division problem, and then we're going to apply the rules of division. And then, if necessary, we're going to simplify. Okay, we're still following those same procedures. So first, we have 2 3/4 divided by 1/8. Okay, you've seen this before. Now, instead of changing it to a multiplication problem right away, we have to deal with this mixed number. Okay, so let's change this mixed number into an improper fraction. So I'm going to come down here and write it just kind of spaced out. So I know I'm going to do 4 times 2 and then add the 3 in order to change this into a mixed number and keep the same denominator. 4 times 2 is 8 plus 3 is 11. So this is equal to 11 with the same denominator, fourths. Okay, so 2 3/4 is equal to 11/4, and then I'm going to divide that by 1/8. Now this looks exactly like the division problems we just had in the previous examples and try-its. So now we're going to rewrite this as multiplication. 11/4 times 8 over 1. And then I'm going to rewrite this as 11, but then when I transfer the 8 over, I'm going to factor it out because I see I have a 4 on the bottom. So I'm going to factor 8 into 4 times 2. And then 4 times 1 is just 4. I don't need to write that 1. Okay. And then I'm going to cancel out my 4's, and I'm left with 22 on the top. And then if I'd written that 1, we would see that there's a 1 on the bottom. Anytime you have stuff on the top and there's nothing on the bottom, you know that there's a 1 there, and that is equal to 22. The answer to this one is 22. Okay, so now it's your turn to try it and make sure that you understand it. So we have 2 problems. They both have mixed numbers in the denominators, but once again, you're using the same exact steps, you're going to rewrite it as division, and then you're going to apply the rules of division, and then you're going to simplify. Okay, so go ahead and pause the video, do it on your paper, and then come back and check your answer. The first one I'm going to rewrite as a division problem, 5/7 divided by 1 2/5. Okay, now I need to deal with this mixed number. 5/7 stays the same, divided by 5 times 1 is 5, plus 2 is 7. Keep the same denominator, 5. Okay, so I have 5/7 divided by 7/5, and then I'm going to change that into a multiplication problem. 5/7 times, take the reciprocal of this, which is 5/7. So I end up with 5 times 5 divided by 7 times 7. 5 times 5 is 25. 7 times 7 is 49. And this is not reducible. There's no number that divides evenly into 25 and into 49. So my answer is 25/49. Okay, same thing here. We're going to change this into a division problem. 8/5 divided by 5 times 3. Well, I'll rewrite it this way first. There we go. And then I'm going to take care of that mixed number. 8/5 divided by 5 times 3 is 15, plus 1 is 16. Keep the same denominator. 8/5 divided by 16/5. Now I'm going to rewrite that as a multiplication problem. 8/5 times 5/16. Now this is nice. I have a 5 in the bottom and a 5 in the top. I have an 8 in the top and 16 in the bottom, and 16 is divisible by 8. So I'm going to write 8 times 5/5 times, and then I'm going to factor out the 16. 8 times 2. And I can get rid of the 5s and the 8s. And I know that when I canceled everything out on the top, that I have a 1, and on the bottom I have a 2. So the answer to this is 1/2. Check your answers. If you don't understand, rewatch it, watch step by step, and see why you missed what you missed. Check Google Classroom for your assignment. If you have any questions, let me know. I would love to help you.